the example I did with the basketball, throwing the basketball, and it had a graph that looked something like this? Well, if you think about it, there's not that many really interesting points on that graph. Where it lands is probably interesting. Where it started, at what height, is interesting. This point, and maybe this one at the top is interesting as well. Where the top there, is it there? Yep. Because where I start, if I'd started a bit lower, I may have had a different trajectory. But these points, these two, where it crosses the y-axis, this one is where it crosses the x-axis, and this one is the line of symmetry. So the line where it's symmetrical about. So it's halfway between these 2 points. So anything, any object that is thrown, is moving, it could be an Angry Birds game, anything like that has to follow a rule that looks like a quadratic equation, because they're the ones that produce these parabola shapes. So this is also a parabola shape. So, yep, and we're going to look at the equation for this one. Let's have a look at x minus 3, x plus 2. So how would I expand that out? Well, I've drawn it here. So what's in here? X times x is x squared. That's this first term, x squared. Let's have a look. What about the next term? X times positive 2x is plus 2x. So x times 2 is 2x. Add that in. Then I've got minus 3 times x. So that's my minus 3x here. So minus 3 times x is minus 3x. And minus 3 times plus 2 is negative 6. So here I've got negative 6. So this works out to be x squared minus x minus 6. And what I want you to notice is here the 2 and the 3 are being added together to give you minus 1. Here they are being multiplied together, so this is minus 3 times 2 to give you minus 6. And if you remember the game that we played, what two numbers add to give minus 1 and multiply to give minus 6? So you have to say to yourself, okay, minus 6. I could have minus 6 and 1. I could have minus 1 and 6. I could have 3 and minus 2. Or I could have minus 3 and 2. Are there any more? Well, they're the factors of negative 6. Now let's see what happens when I add them together. This gives me minus 5. This gives me plus 5. This gives me plus 1. This gives me minus 1. So it tells me that these two have to be the factors that I'm looking for. X minus 3, x plus 2 equals x squared minus x minus 6. Being able to factorise like this, so being able to go from this to this, is important for when you want to look at graphs, because this tells me here and here tell me when those two numbers up the top there multiply to give me 0. So if I multiplied that and I got an answer of 0, what would x have to be, or what possible values could it be? So what I'm asking you is x minus 3, x plus 2, when does that equal 0? Because that's these 2 points right here. So what values would give me 0? How do I get something to equal 0? This is stuff you probably did 10, 12 years ago at primary school. How does that work? Can you see which two values would give you 0? What would happen if I put plus 3 in here? Can you see that 3 minus 3 is 0? So 0 times 3 plus 2, which is 5. 0 times 5 is 0. So one of those solutions is x equals 3. That's that one right there. Well, the other option is, can you see what the other option is? What would make this bracket 0? Because anything multiplied by 0 is 0. Well, the answer would be minus 2, because minus 2 plus 2 is 0. And minus 2 minus 3 is minus 5. So minus 5 times 0 is 0 if x is minus 2. And that's this point over here. The negative 6 comes down here. This is negative 6 here. That's where it cuts the y-axis, because that's when x is 0. So if I put x is 0 in there, I just have minus 3 times plus 2. So I just wanted to show you the picture that went with it, because we spoke about the basketball example. And when it's written as a multiply, I can easily find those zeros. I can easily find where it cuts the axes. That's the beauty of being able to multiply. If I asked you to find x equal to 0, written as a plus or a minus, it's very, very difficult. You just have to do guess and check. X is 1, 1 squared, minus 1, minus 6. No, it's not equal to 0. What about if I did 2? 2 squared is 4, 4 minus 2 is 2, 2 minus 6 is minus 4. Doesn't equal 0. Can you see how much more efficient it is when it's written as a multiply? So finding zeros, the easiest way is when it's written as a zero, when it's written as a multiply, sorry. So I'll do one more example and then I'll let you go. Okay, let's have a look at this example. P squared minus 11p plus 30. So I'm looking for two numbers that add to give minus 11. Oops, sorry. And they multiply to give 30 plus 30. Alrighty, so let's have a look. Alright, let's think about it. 30, so I could have 1 and 30. I can have 2 and 15. I can have 3 and 10. Can I have 4? No. Can I do 5? Yep, 5 and 6, which means I could do 6 and 5. What about 7? 8, 9, 10, 11, 12, 13, 14, 15. I'm halfway, so now I know that I've got them all. Are any of those actually going to give me negative 11? They're all both positive, so it's never going to make minus 11, is it? So they both have to be negative, because when I multiply a negative number by a negative number, that would give me a positive number. So when I add these two together, minus 1 and minus 30, minus 31, it's not that one. Minus 2 minus 15 is minus 17, it's not that one. Minus 3 minus 10, when I add that together I get minus 13, it's not that one. Minus 5 and minus 6 is minus 11, it's that one. Alrighty, so now what I do is I rewrite out my minus 11p as, and it doesn't matter which way you do it because it always works out, you can test that for yourself. So I'm going to rewrite my 11p, so I'll write an x, minus 6p plus 30. Okay, so all I've done is rewrite minus 11 as minus 5 and minus 6. Now you're going to do exactly what you did in the previous exercise. So what's the common factor in this first lot? P. P times what gives me p squared? Has to be p. P times what gives me minus 5p? has to be minus 5. That means I know that the next bracket here has to be this same factor, p minus 5. So let's have a look. If I take 6 out as a common factor, I'm going to get p. If this is going to be p minus 5, this has to be a minus out here, because minus 6 times p is minus 6p, minus 6 times minus 5 is plus 30. Now you can do exactly what you did before. This is the common factor, and you'll take that out. So let's take that out. That's p minus 5, and everything else that's remaining goes in the other bracket, p minus 6. And then it's factorised. So I've gone from expanded form, addition, to multiply, factorised. So you just ask yourself, what two numbers add to give me the middle term and multiply to give me the last term when this is 1? That's all we're doing at the moment. So yeah, so which ones they add to give the middle term and they multiply to give the last term. Go through the factors, rewrite it, and you'll have solved it.